Let's take a quick look at some of the laws that govern how we manipulate numbers in algebra. The first law we want to look at is commutative law. Commutative. And these laws apply to addition and to multiplication. In some sense, they will, well, we'll see how they apply. The commutative law says that it doesn't really matter which term is first. If we are adding two terms, it's the same thing to add them as w plus 3 as it is to add them as 3 plus w. And for multiplication, r times t is the same thing as t times r. And just as a quick example, we can say, well, if w were 1, 1 plus 3 is 4, but 3 plus 1 is also 4. It doesn't work the same way with subtraction, right? 3 minus 1 is 2, but 1 minus a 3 is a negative 2. So commutation doesn't really work with subtraction. The only time it can work with a negative number is if I have 3 minus 1 and I were to change that to a negative 1 plus 3. In essence, I understood this to say 3 plus a negative 1, and now that it's addition, I can move that whole term over, this whole term here, and make it negative 1 plus the 3. The same thing with multiplying numbers. Let's say 6 and 5. 6 times 5 is 30, right? 6 groups with 5 things in them, I would have 30 things in all of my groups. I'm not going to make anybody count that. I just wanted to draw. But that's the same thing as saying 5 groups of 6 things. That's also 30, right? And again, that doesn't work with division the same way as it does with multiplication, in that 6 divided by 5 is not the same as 5 divided by 6. They are, in fact, inverses of each other. And it could work if I were to say, well, 6 divided by 5 is the same thing as saying 6 times 1/5. This much is true, but this is not true. So that's the commutation, that's the law of commutation, or the commutative law of algebra. Let's take a look at the associative law. An associative has to do with grouping, so we can say associative means grouping. And again, for addition and for multiplication, it doesn't matter which we do first. We can do m plus the quantity n plus 2. So let's say 3 plus the quantity 4 plus 2. Well, that's 6, and 3 plus 6 is 9. Well, we could just as easily have done m plus n plus the quantity m plus n plus 2, or 3 plus 4 quantity plus 2. 3 plus 4 is 7, plus 2 is 9. That's not a proof, but it shows you how the associative property works. The same thing with 5 times the quantity p times q. If we were to use, that's the same thing as saying 5 times the quantity, 5 times p times a q. So if I were to say 5 times 3 times 4, that would be 5 times 12, or 60. And that's exactly the same thing as 5 times 3 times 4, which would be 15 times 4, which is also 60. So that's the associative law. The associative law has to do with grouping, which operations I'm going to do first. But as long as they're addition or multiplication, it doesn't really matter. We're asked here to multiply a quantity. This is 4 times the quantity a plus 1. And what we're doing now is we're multiplying over addition, across addition. And this is a process we call distribution. And you need to get very good at distributing because you will be doing a lot. And quite simply, this statement here, 4 times the quantity a plus 1, is the same thing as saying 4 times a plus 4 times 1. I've distributed the 4 to the a and the 4 to the 1. And in that case, that's just 4a plus 4. And it works the same whether it's addition or, let's do this as subtraction, right? C minus, we'll say 2. C, when I distribute my 3 to the c and my 3 to a negative 2, I get 3 times c, which is 3c, and 3 times a negative 2, a positive 3 times a negative 2, gives me a negative 6. That's distribution. The opposite of distribution, we'll call this the distributive law. Distributive law. The opposite of distribution is to factor. When you look at 24x plus 24y, I notice that both terms have 24. Remember, a term is something that's separated by a positive or a negative, by a plus or a minus sign. But I know both terms in common have 24 in them. So I can divide out the 24 from both terms. I don't know why I always draw that little sign there. I can divide out the 24. And when I divide out the 24, I am left with those cancel to 1, those cancel to 1. I'm left with x plus y. Notice that that looks almost exactly like what we had in the previous one before. That was the before picture. We have a quantity, we have a number times a quantity. Here we have 2 terms, and I turn those 2 terms into factors. I factorize those 2 terms. Take a look at 7x minus 21. Both terms contain a 7 in them. 7 is 7 times 1. 21 is 7 times 3. So I can extract a 7. I can factor out a 7. And those cancel to 1. Here I factor out a 7. If I divide out 7, those will cancel to 3. So it is 1x plus 3, or simply 7 times the quantity x plus 3. This is factoring, and we will be doing lots and lots of factoring.